And so I think people are underestimating modern architecture, WMS and WES systems, because they're not all created equal. A lot of people slap a new name, a new acronym on a system and say, yep, it can do that. And then you find out after you've adopted it that everything they built is duct tape and baling wire. And the second that you pull out one of the Jenga stacks, the whole thing comes crashing down.
Hi, everyone. Welcome to another episode of The Automation Journey, the podcast where we talk about all the various topics you might face along the way in your own automation journey. I'm Marissa Dierlam, head of marketing for TGW in North America, and your host today. Joining me in the studio are two special guests, friend of TGW, Shari Christofferson, and my colleague, Rebecca Call. Before we dive into what I think is going to be a really fun and engaging conversation, do you mind introducing yourselves?
Not at all. I'm Rebecca Call with TGW North America. I lead the process and software consulting team and the system integration management team.
I'm Shari Christofferson, president of Connect Incorporated, and I wear many hats.
I can believe that. Well, I'm really excited to have you here because I think what you guys do at Connect Inc. is so interesting and kind of we'll be able to dive into a lot of things around connectivity, data analysis, what happens on the warehouse floor, and the interconnectedness between people, data, hardware, software, all that good stuff. So I'm really excited to dive into things. Let's kick things off, though, by imagining what is probably someone's worst nightmare. They invest in automation, it goes live, everybody's excited, and then 6 months through, they're not getting the results they expected. What might be happening in a scenario like this?
I think we see this all too often in the industry. And it may not be like a full system. It may be the shiny toy sitting in the corner that nobody ever gets into production or operation because it just doesn't do what it was designed to do. Often, individual systems don't fail, like they work, but the whole, connecting all of those different pieces of automation, pieces of material handling equipment, it just doesn't flow. Like it'll oscillate, it'll continue to just slug through the system and you just don't get the results. So it's a pretty bad day if you can imagine.
Yeah. So how would you even begin to diagnose what's the root cause of that sort of thing?
Yeah, I would say the main objective is to try to capture the problem, which in these complicated interconnected systems can kind of be like often referred to as chasing a ghost, right? But to be able to nail it down and say, oh, at this moment, this is when it was happening, and have a clear picture of what all those systems are doing is a great way to start.
I think one of the things that Shari highlighted is the ghost in the system. When you have all of these independent systems, everyone can say, well, no, my system's working great. This robot's working great, or this server's functioning fine, or the piece of automation, and everyone's playing like the scarecrow in the field. It's everybody else's. And so it looks like a ghost in the system because you're looking at something saying, hey, everything is healthy. It must be something else. But the something else says, no, everything's healthy on my side.
So then I imagine it pretty much all comes down to data. And so I feel like that's always the answer. It's like it comes back to data. If you're not actively recording movements, like it's going to be so much harder. So let's maybe talk into what sort of data points do get captured in a warehouse. Rebecca, on a high level with Works, what data are we capturing there?
Data gets captured all over the place. So we have this compartmentalized, containerized system, and all of those individual components are constantly talking to one another. The challenge is sometimes not a lack of data, it's too much. You have so much data from so many systems that you don't even know where to start. So you have transactions from the host communicating to a downstream system. You have transactions, the PLC, every time a box is scanned across a system. Every time a user logs in, every time they perform an action. All of those are data transactions. And so imagine looking for that ghost in a system that just captures gigabytes and terabytes worth of data on an hourly, daily basis.
So then there's a lot of data coming in. Do things ever get missed as a result, or are things usually scanning pretty well? Or does human error ever come into the picture?
Yes, on all fronts. So occasionally there will be systems that don't log transactions or don't communicate to ancillary systems. So if you have a warehouse execution system that's performing, let's say, pick messages. You're at a goods to person station. Someone is transferring a unit from place A to place B. Not only could it be missing because there's a connection down because the system, that particular message queue is not functioning, but also there could be latency. And if a different system is relying on real-time data and not receiving real-time data, it may as well be missing.
So I feel like that would make it even more complicated if, first of all, there's a ton of data to sort through. Sometimes data is missing or wrong. That makes it so much harder to then even begin to diagnose, right?
It does.
Yeah.
It does.
Yeah, and being able to pinpoint really when the problem happens, because these things are all happening in milliseconds in a system capacity. And yeah, there can be alerting and things, but there's usually a person or a task at the end of all that,
Right.
that's impacted. And that's a data point too, right? And the frequency of that incident also becomes a great addition to all of the systems data as well. So that's one key piece, is that like voice of the front line or of the supervisors who are actually watching all these things happen, because like you say, it's fast. It's fast. It's a lot of transactions, a million ways to go wrong in the West, right?
Yeah, so if Works is more looking at like product flow and that sort of thing, Connect Inc. is where you kind of get the worker touch point. Do I understand that correctly? What sort of data does Connect Inc. look at?
Yeah, that's a really good question. So I like to think of it as just a conversation. There's a conversation going on between servers, between networks, and then eventually all the way down to the frontline worker. And so that conversation is happening over wired and wireless networks. There's a kind of a lot of times an invisible component to it as well. There's over the wire, there's over the wired, and it's listening into that conversation. So it's not so much concerned like, did the warehouse management system transaction complete? It's more interested in, did that packet complete? Because there's normally be many, many types of conversation elements like words and syllables that are happening to complete that overall warehouse transaction. So I think like that's a key piece. And because that's also at millisecond level, you have to tie all that together to say, yes, what I'm saying into this microphone made it to the speakers or made it to, over the phone is maybe a more common type of analogy. So we're looking at, how did that conversation go? A lot of it's invisible and it's through multiple systems. And how did that all add up to give the end user the system performance it needed? And that's where the feedback loop comes in.
I think that's interesting, because if you look at like a day in the life of an order in a warehouse, we not only have the flow of inventory that then constitutes an order, but you have transactions that go along with all of that and an identity change along the way. So if I look at inbound to outbound, I receive something and it has a totally different identity. I may have a pallet, I may have a case that comes in, but that case is full of a bunch of units. At the time that the case or the pallet comes in the door, it's not yet for an order. But if that case or pallet comes in, then gets decanted, broken down into individual units, then gets picked for an order, then gets packed up and shipped out the door. But if any message along the way failed, then you create piles of downstream system errors. Because if the case didn't get recorded, then you have no such thing as a unit. If the unit doesn't exist, then you can't fill an order. And if you can't fill an order, then you can't satisfy a customer demand. And so all of those transactions have to succeed, but also all of those transactions have to be properly communicated to the ancillary systems. And it may be a combination of 10 different material handling devices or a couple of people along the way.
So then where does all this data get stored, and how does it all get integrated together? Like, how does what Connect Inc. does get integrated with a WMS or things like that?
So starting with the WMS, if we deploy Works as a WMS or even as a WES on premise, then for each transaction, that inbound case maybe there's a host system that actually owns the inventory at that time, or maybe it's even upstream from there. It's an ERP system. So that enterprise system receives the inventory and says, okay, now it belongs to this warehouse management system. The warehouse management system then has to accept that ownership. And all of that is done through communications like the telephone call that Shari mentioned. So then that warehouse management system then communicates to the downstream systems. The downstream systems then independently and individually communicate up to the warehouse management system. And as those transactions happen, the communication for them happens right along the way, which is, I think, where, Shari, your technology comes into play, is as those transactions happen and as that communication happens, you're listening to all of those telephone conversations.
Yeah, I've never heard it put together so well. I'm going to have to remember everything you
store
said.
that one for later.
Yeah, it's very, very clear. Yes, and especially when you have a device of some sort at the edge, whether it's an automation equipment, just moving things like a goods to person, or a mobile person walking around, even a print job.
Sure.
You know, it seems so simple. A print job, who cares, right? We all do it. We all print. But boy, if that barcode sticker doesn't come out for the box that it's supposed to be going on, that's going down that line, everything stops. Because now, how are you going to get it on the truck? You can't.
You bring up a good point, because if you're off by 2 seconds, right, that's every order is getting the wrong barcode. Every order is off by 1. And so I may get your newly blazer, and you may get my sweater. It's
not a bad idea.
And we're switching outfits for the day.
Why didn't we think of this? We'll have to let them know.
So then once all this data is captured, who at the customer level is usually looking at this data or even knows what to do with it?
I think it depends on the customer.
Yeah.
Okay.
So some customers are better than others, and some customers have expertise in different areas. So if we have a customer who's incredibly technologically savvy and they've lived this rodeo before, then they may be looking at the data. But they may also need some expertise like Shari brings to the table if they can't pinpoint where that ghost is. They may not have the technology, or they may be wading through these terabytes worth of data. And if it's an intermittent problem, it only happens between the hours of 2 and 3, then you can do everything you want. You can set up a proper test. You can have people on standby, but it's overwhelming, the amount of data. So Shari, can you explain, just for my benefit, if that's the situation where, hey, I know that this intermittent problem happens between 2 and 3, how would your system kind of integrate or help that situation?
Yeah, you know, it's great you brought that up. Thankfully, we just had a case like this. I think it was an ASRS or some part of that flow. And it was exactly that. They had multiple levels of service partners involved. As you know, it takes a village to support these things. They look simple. The box goes there, it goes there. But there's, like you mentioned, there's so much going on. So everybody was working from a different set of data. You brought this up earlier too. And they all knew, and they all checked their logs. And at that time, nothing seems out of, why does this machine keep spontaneously dropping connection and restarting? Basically, they had to go reset the system. It would just get bungled up, right? Yeah. And it's okay. Now they know it's happening between 2 and 3. Okay, no problem. And so what we're able to do is actually see that conversation in a way that nobody is all at once, seeing those live, that live conversation that's happening, because one server that they're monitoring is sending the message. Another part of the machine is getting, maybe multiple parts, is getting the message or supposed to get the message. But what happens in between is unclear. And that's where either side, and of course, just like a straight network monitor can tell you that those pieces of the network are functioning properly, but it's not telling you really what that conversation was. And sometimes it's as simple as the conversation goes, "Hi, I'm closing the connection now. I got a bad protocol error," and nobody can see that in the logs, for example. So that's one thing that happened recently. It's typically not that big a deal, but we don't always know what it means, but we can capture the problem and then deliver it to the responsible party.
So then on top of the software that's detecting these things, you guys have a services team that's also kind of actively looking through it. Is that Do I understand that correctly?
Yes. That's something that, because I know the word data analytics is, you brought it up too, it's a huge bucket of things, and lots of things you can do with it, all kinds of analysis, all kinds of insights that you're supposed to gain from it. So what we're very focused on, there's a problem. If oftentimes that service part is the fact that we've set up the software in order to detect the problem, or we get that insight from the front line. We give a mechanism for somebody to report that there is a problem. It feeds into the logging. Software does most of the work, but someone has to look at it and say, yeah, this is a problem. It's repeatable. We have to like run another algorithm through the historical data to make sure that it, yes, this is really a problem. And that's the service we provide. And you deliver that through, the documentation, and the data itself goes through an interface, a portal, a dashboard. But I got to say, a lot of it happens through the people. And I know your team and everybody at TGR is people as well as being excellent technologists. Like you got to talk to the people. And you have to talk to your previous question, who are the stakeholders? Yeah. And that's where a person goes, oh, this is happening, and I know that Rebecca really cares about this, or Marissa's team really cares about this, and then somebody has to reach out.
And I think, Shari, you brought up a good point, because a lot of times we're behind a computer screen.
Yeah.
And so as we're trying to diagnose these issues, we're looking at a computer screen saying, hey, here's the send, here's the receive, here's the send, here's the receive. And you look at it and you say, yeah, everything's fine.
Everything's fine.
But if you look up, you see, here's the send. Wait a second, I don't see a box. And then you see a box and I don't see a send. And so you have to marry that physical world with the virtual world. And sometimes you're blind to it because you're behind a computer screen looking at a perfectly healthy system that actually has 10 seconds of physical delay.
Yeah,
it's wild, isn't it?
I think that's why it's so important to think about not just technologies, because they're not perfect always, but the human aspect too, and how do these things all marry together, right? Like you need all the different perspectives usually to detect things.
Shari, you and I had an experience a few years ago where the human element came in and actually helped us solve the problem.
Right.
So we had, and again, we have systems and we think they're great. We're looking saying, yep, everything's clean, everything's clean. Only the person wearing the device out on the floor, Shari, if I remember correctly, you added something into that mobile device where they could flip over to a new tab and essentially put a mark in the sand so that I'm marking within those gigabytes worth of data in a particular log. Hey, flag on the play. There was no box there. That same type of thing. Exactly. Do I remember that correctly?
Yes, that is something that seemed silly at the time. I kept hearing my engineers say, can you let us know when the problem happened? Right? And I kept saying, this just seems, I'm from outside the industry. I'm not an engineer by trade, so I was like, come on, this seems odd. Why, with a digital device in their hand, are we asking them to go get on their phone and call us and try to describe what happened when they've got this digital mechanism right on their hand, and we're in the network, we can communicate with these devices. So we were like, light bulb, okay, how easy is it? It's super easy. And it turns out that it's a very simple thing to do and set up, but it makes all the difference because what was happening before, even in that experience, was that there was, and this is still the case, I'm sure if you ask a lot of people, somebody is tasked with walking around with an Excel spreadsheet or, a clipboard, and walking around to the operators and saying, hey, did this happen to you now? Or when did it happen? And they get down and it's so vague. And then and then the computer person who's watching the send and is receiving this like input, trying to go back in time, trying to match it all up. And it's not millisecond timing. At least if someone's reporting, it's usually within a second or two of the incident that happened. So you don't have to go too far back.
The window that you're looking into is much smaller.
Well, and if you look at before the application was running on the device, I'm reporting the issue or I'm talking to the person with the clipboard. But I had it and it was like 2 aisles back.
Right.
What time is it? Okay, do you know how many log lines that is? That person is going to be looking for a day to see that 2 minutes worth of transaction data.
Yeah.
So when you're diagnosing, trying to find the error, find the ghost, as we've been saying, what is the role of real-time data versus like look-backs, historical look-backs, or maybe even predictive? What role do these different types of data play?
So in a host system, when we're talking how many transactions fail, you're essentially doing kind of a cross-reference. You have your warehouse execution system and your warehouse management system, and you're saying, okay, I picked 42,000 units in this hour. Well, I picked 41,998 units. Trying to find missing data is awful. Imagine trying to compare those two and to find what's missing. So then, Shari, if you want to talk about how your data.
Sure. Yeah. I and that's the key. You know, we may not have all the data because, as you mentioned, you have your server side logs. And that's another thing too, right? The look back problem is that, I didn't have that level of logging on at that time, right? Of course you didn't, because why would you? Because logging on those bigger systems takes up a lot of memory and can shut down the system itself in many cases, right? So people don't put the logs there, they wait, and then that's the problem. That's the problem recreation problem issue. Is you then are going to wait for it to recreate. And aside from that, 2 to 3 p.m. Problem that comes up, many of these are death by 1,000 cuts, which is lots of small incidents, latencies or disconnects or whatever's happening that happens spread out over time, which makes that walk around and ask a person exactly even more irritating and frustrating and pointless. And then so when you can record, you kind of create a recording that is enough, and that's the conversation. And in that conversation, if you start looking into the data more, you'll start to be able to find things besides just time. You'll find other things that match up with what the server was saying at that time. And if you know what the server was saying at that time, then they know that they can look back in their their logs and try to line it all up. And so it's an effort nonetheless, even if you do have the real-time data as well.
And I think it goes back to our like disappearing box or missing box analogy. If we show in our logs that a box crossed a scanner at 10:22 and 38 seconds, then Shari can look, hey, what happened at the network? And those missing pieces between systems now become visible. So instead of playing the scarecrow game of, hey, the host system is fine, the warehouse execution system is fine, the warehouse control systems are fine, and all of the equipment's fine independently, you can fill the holes. You can find out, okay, yes, you sent it, but they didn't receive it until this time. Here's what happened in the void.
The void.
Question that's coming to mind, Rebecca, how would this work then with like if someone added a digital twin into the conversation too? Like how would that even work with all these different pieces that we're talking about?
Digital twins are amazing. like no one, I haven't seen the perfect digital twin yet, but we're getting close. So being able to visualize what actually is out on the warehouse floor, so you take away that element of, hey, I just saw a box. Wait a second, there's no box there. So that you align those, so that you fill the gaps with what actually is happening on the warehouse floor with every single piece of equipment. If I have a photo eye that trips, that is immediately before the scanner, and then the scanner doesn't scan, I can look at, hey, I have a problem here in between this particular photo eye that is half a meter off of that particular scanner, and now I've pinpointed where my ghost is. It's right between that segment. So just like we were talking about where that void in communication happens, now I can look at the health of my system, the individual component health of my system to see, hey, when the box goes there, then the scanner fires, but then the next photo eye doesn't trip for 4.5 seconds. Well, if I know that that's 12 inches of conveyor, then I know that that's a problem because, well, if you don't go, much faster than 12 inches in that many minutes, you have a bigger problem.
Yeah, that's interesting.
In this case, you're taking a visual replay or a visual problem capture. that you can rework.
It's kind of the marriage of everything.
Okay.
So think of your simulation, your emulation, and your digital twins as gradations. So you have simulation that is like this virtual reality.
Which
Hey,
everyone
if I do
loves.
this, if I do this, then this will happen. If I input this other thing, then we can expect.
Okay.
Your emulation is, hey, I want to communicate across things as if they really existed.
Okay.
And I want to use the same protocol talking to a PLC that I will use with the physical PLC. Now your digital twin is a combination of those two and this addition of a layer of a digital representation of a physical element. So every photo eye, every mechanical part is recreated in this digital world with constant communication flowing back and forth between the individual elements with bidirectional information. So that information coming from the physical system is saying, hey, I just got this box. Hey, this user logged in. Hey, this inventory exists in all of these systems. Hey, I just, consumed one of them. But the other direction flow can happen as well. And this is where I think we as an industry have an amazing future.
Yeah.
Because if your digital twin can say, hey, look, your average life on the component of your shuttle, your brushes, which is the most common part to go out, your average life is, let's say it's 6 years, and I'm making up numbers, 6 years, 14 days. This one is 6 years, 15 days old. And I have had 32 errors in the last 12 minutes. Hey, you might want to go out and address this before it impacts the system.
Sure.
And
Predictive.
yes, that predictive, it's like you have the AI engine in your pocket where it's just, hey, by the way, go do this. Hey, by the way, you might want to look at this. It's like the most advanced operator, the most advanced field service tech at your beck and call, and giving you that predictive and that recommendation engine to say, hey, you might want to do this. So you're resolving the problems even before they become a problem.
Holy grail.
Isn't that crazy?
It's really exciting.
So I want to pivot our conversation a little bit. We've been kind of getting into some of the details, but I think it'd be interesting to talk a little bit more about the ROI or the payback for these things. When people are investing into their warehouse, they see the hardware, they see the technology, and so that's usually what's top of mind, less on these invisible connectivity layers that we're talking about. So how do you explain the ROI or payback for things like a Works, WMS, or WES, and Connect? Where does that sort of come from?
It's funny. I posted on LinkedIn yesterday a little AI graphic of myself holding a surge protector, because that's kind of how I see software. Software is this surge protector with a whole bunch of different technologies all plugged into it, and software is what holds it all together and makes it work, powers the system. And this AI recreation is me holding the surge protector with cords going out to a pallet ASRS and a shuttle system and I'm smiling, saying, you think all software is the same? And then it starts to spark and smoke and everything else, because all software isn't the same. It's easy, like you said, when you're looking at equipment, you're seeing, okay, this is what this cost. And it's even a little easy to say, this is what the software costs to run this thing, this piece of equipment in front of me. What's not as easy to see is the value of different technologies, different software that allows you to unplug something and plug something back in without a huge amount of change management, risk to the operation, and additional cost. I was talking to someone the other day, and their change for a new vendor for software was $2 million. $2 million for no tangible benefit because of the risk that it introduced to the operation. And so if you look at the software value as risk mitigation and future-proofing your warehouse. We don't build warehouses that are just going to go live and go dark in 2 years. These are 20, 30, 50-year buildings where, yes, we're going to continue to evolve. But what if your surge protector could introduce any type of plug, could introduce any type of new system without risking everything already in your system and still allow you to grow? Industry's not going to stay the same. It's never stayed the same. And so that opportunity cost is immense.
Yeah, I've often been bothered, like when I got into sales more in operations and in the supply chain, they'll often they want to talk ROI. What is my return on investment? And I'm like, that's difficult, right? I mean, I think this is part of what you're getting at too. It's difficult to say the return on the investment is that you're going to create 5 more, like typically that's a ROI argument, right? You take 5 more widgets per dollar or whatever. But when you're talking about, you have put X millions of dollars into creating this 30-year DC, and you've invested in the software and the hardware and the systems and the connectivity and everything. You don't need an ROI to build for example, redundancy. People say, well, I don't have those types of problems. Why would I need this type of visibility? And the answer is everything Rebecca was just talking about with the digital twin and having that ability to move forward and innovate, because you have all the data, you have all the inputs and the outputs that happened in the past to create that digital twin. But you also have the ability to avoid all of that extra cost that's going to happen when the ghost pops in the system. And it's a small, tiny, it's a big payback, because it's going to happen in your every year, a little rain is going to fall on your perfect world, right? And it happens.
Yeah.
And you want, so the payback is from this perspective of an operator and somebody who is charged with making sure those boxes go out the door, that I get my jacket and you get yours, they need to look at it, and everyone uses the word proactive. And this is a case where having the right software, having the right support, having the right visibility, it's not so much an ROI argument, right? You use the word payback because it's really about assurances.
Yeah, it's ensuring the lifetime value. Yeah. It's minimizing downtimes, which can be extremely costly. It's a little bit softer in some regards. Yeah.
I remember when I was probably 10 years old, because numbers stick in my head, but I remember my dad coming home, because he's been in the industry for forever. My dad came home. He had to go out to work on site during peak period. And he told me, and again, I'm 10 years old, and that was more than 20 years ago. So the dollar amounts are different now. Yeah. But 1 hour of downtime was $1 million to the customer.
Wow.
Right.
1 hour of downtime. And so imagine if you can speed up your go lives, if you can reduce your downtime, if you can keep the people who you're paying on the floor, or you can keep that capital expense that you've spent millions of dollars on, if you can keep it running for an hour more every 10 days, then that's your payback.
Yeah, for sure. So maybe besides improvements to operational diagnostics, what other benefits come from connectivity between workers, technology, and software? For example, does it make it easier, kind of like you were saying, to add more plugs to the surge? Or, can we do more things like AI in the future? Does it build up like a foundation? What are some other maybe benefits?
So in the Works application, it absolutely does. Works is a suite. And so it's this combination of whatever you need it to be for that particular site. So being able to take different elements and plug them in, whether they're physical elements or logical. So an AI engine. Hey, your SLAs are met for the day. You can BTO employees if you want. And so that's just payback. Or, hey, you're running behind. You might want to deploy 3 more workers on pick centers 5, 6, and 7 because you're going to compromise SLA. And if you compromise SLA, you upgrade their shipping, which costs you money, and so you can save that money. That's already in the work stack today. We call it that recommendation engine. But we never know what's going to come next. AI is the buzzword, right? Everybody's talking about AI. But AI, unless you use it to a benefit, I like my AI engine where I can pull out and say, hey, tell me more about Genghis Khan or anything at the drop of a hat. But if you don't use it for a value within the warehouse, did it really benefit you?
Sure.
It's nice to have, but where's the value?
Yeah, I've been, we all have our own AI journey. And as I use it more, just on a regular basis, I just realized that it's all data and context, right? The data has to have the context in order for it to be meaningful especially for an operational standpoint.
And modern. I don't really care if Joe Smith picked 1,200 units 4 years ago last Thursday.
Right.
I do care what's the trend, what's the value over time, what is yesterday, what is last hour. So data in context with real-time values
Right.
becomes more and more valuable.
And, you know, going back to the payback argument as well, in when to change the brushes, right? Or when, and you see this a lot. Oh, hey, you know, it's time to refresh your such and such. Why is it time to refresh your such and such? Well, because the vendors decided it's time for you to refresh your, no, you know, like you know, it's like when, I always have this argument with my husband, like he wants to change the oil in the car every 5,000 miles to like the mile.
To the dot, yeah.
And I'm like, yeah, but I put synthetic in there and I'm checking it to make sure that it's not getting
viscosity.
right.
Yeah.
And so I can't wait for him to see this because this is like an ongoing argument. So I'm like, so you might be able to get like another 3,000 or maybe even another 5,000 miles out of that. But it's just that people don't have the data to know. So from a standpoint of like, oh, it's time to refresh your access points or it's time to refresh whatever. And it's like, okay, well, what's the data? I mean, I would be asking, what's the data on that?
Yeah.
Like, did I really somehow exhaust the wireless connectivity of my access point that I just put there like a year ago? Or maybe it is really bad. And so not knowing, I think, has a cost.
And I think that goes back to, you mentioned the brushes example. The context is, hey, you know, you have this brush and it's over the time. You know, your average is 16, I don't even remember what I said, 16 months, 4 days or whatever. But that's the average. And it has had 32 failures within the last 24 hours.
Right.
Those combined still, we're not going to eject the shuttle and make you or create a robot to change the brushes for you. There's going to be a human element to that, but give you the context and the why.
Right.
Don't just give me a, hey, it's 5,000 miles, done and done, because that's always going to be on the side of caution. And sometimes you're hemorrhaging money that way, especially in these large automated systems. If you have your little, you know, AI bot in your pocket that maybe is not telling you interesting historical facts, but is actually telling you, hey, this is why you can do this. Hey, SLA is met. VTO your employees, or hey, you can get ahead of your orders if you do this, that, and the other. But coupling that with a brain that says, you know what? I know that we're going to be short-staffed tomorrow because we have this all-hands meeting, so I'm going to work ahead. And that recommendation engine, that's great to know.
Yeah.
But I'm not going to action it.
Well, this has been a super interesting conversation. I really appreciate you guys talking to me about the connection between, you know, floor to you know, the dashboard and everything in between. To wrap things up, I have one more question for you guys. In your opinion, what software, data, and connectivity aspects are supply chain leaders underestimating that they will regret if they don't act on sooner than later?
I'm a little biased here.
You don't say.
A lot biased, I should say. All software is not the same. And just because you could do something doesn't mean you should do something. And so a lot of times people are risk averse. It's scary to essentially do a brain transplant in a system. But I think as an industry, we rely on what has been good enough for so long. We have systems out there that are running host systems from 2008, 2015. Imagine if you had a cell phone in your pocket from 2015. It wouldn't work, and it's just a matter of time. And so I think people are underestimating modern architecture, WMS and WES systems, because they're not all created equal. A lot of people slap a new name, a new acronym on a system and say, yep, it can do that. And then you find out after you've adopted it that everything they built is duct tape and baling wire. And the second that you pull out one of the Jenga stacks, the whole thing comes crashing down. And so complacency and reliance on historical systems, but at the same time, not understanding what that risk is that they hold in their hands. And it could be something as simple as, hey, let's add an AMR to take a pallet from point A to point B. And all of a sudden, not just the AMR doesn't work. The shiny toy's not just sitting in the corner collecting dust. but it compromises their system integrity. And, from 20 some odd years ago when my dad came home and said $1 million hours, imagine how costly those would be today.
Yeah.
The Jenga analogy really hits home. Also because I played Jenga with my nephews last weekend and I didn't do so well. But yeah, that's essentially it. And I see it that way, again, from my perspective, as we see this all the time. You're talking about all these changes that are happening quickly. One thing that we're constantly chasing that has massive operational impacts is the security, IT security, essentially call it network security. People, yes, there's the pulling the string, and sometimes that string is pulled almost externally from the operation, and maybe even we see this with edge technology. You bring in like an operating system, like an Android or something, and Android decides it's going to have its own update schedule. So I in all of that, I think what we're both saying is you usually say less is more, but I think in terms of if you have the right partners and the right types of people in the loop to help you take in the right visibility, process it, and communicate with each other and synchronize data and help everyone understand, you can make changes, you can move forward, you can innovate. But if you don't have, you start trying to pull those Jenga pieces out and you can't put them back in, and then that's when the whole house can come down. So, yeah. Well, I think that's answering the original question.
Yeah.
To some degree. Okay.
Yeah, you're great. Well, thanks so much. Again, I really appreciate it. And hopefully our listeners enjoyed this as well. If you did, please follow and subscribe our podcast on your favorite platform. And hopefully we'll catch you on the next episode of The Automation Journey.